All right, so I guess let's get started. So, hi everyone. This is going to be our presentation for a new thing that we're going to be starting up called ML, Machine Learning Mondays. And today's session is just going to be an introduction to Python, just kind of get everyone up to speed with the programming language that we're going to mainly be using throughout this. So first of all, who am I? I'm Ryan, as some of you might know. I guess I'm an outreach officer for this semester, and I'm going to be the person that's going to mainly be doing the presentations for this program. So I guess because this is our first one, I'm going to briefly go over how ML Mondays are going to work. Basically, today's going to be a little bit unusual, but most of the time it's going to be give or take 25 minutes of active teaching. It's going to be a relatively fast lecture. 20 minutes of some sort of interactive workshop, like going over a data set or trying some learning problem. And the goal of this all is to introduce you guys to some of the interesting areas of machine learning, not necessarily to get a full mastery of it, because that would take much longer than the time we have, but at the very least, give you all a bit more of an understanding and awareness of what is out there to explore. So, overall schedule. As I said, this is going to be a series. ML Mondays is going to happen at this time every week for the next, I guess it's like 9 weeks because there's a break in there somewhere. But we're going to start with Intro to Python. This is a bit like this might be adjusted to some extent depending on the overall interest of people that want to go to these things. But tabular machine learning, computer vision, reinforcement learning, natural language processing, recommended systems, chatbots, and then week 8 is left undetermined for now. Again, if people are interested in something specific, we can try to go over some stuff then. Something that isn't listed on here is every so often there's going to be a presentation on Thursday from a different speaker. It might be from someone from AIS, it might be from a company, going over something a bit more in depth than what I'm doing here. Yes?
What time?
Oh, for the Thursday things?
For the Thursday speaker.
So that, I believe, I'm not sure if it's going to be consistent, but I know the next one is going to be this Thursday from 5:30 to 7, so same time as today. And I'll be going over some of the Python modules or libraries that will be useful, but won't be going over today. With that being said, one quick thing before I go any further. If you have any questions, comments, concerns at any point, please feel free to say something. I will try to respond in the best way I can, but this is supposed to be a learning experience. So if there are any questions, by all means, ask them. I don't bite. But today, sorry.
Ron, before you start, there's a difference between the ML Mondays and then I think the AIM project teams that are Python or whatever that is.
So it's a bit different. So the way AIM works, it's more of for AIM it's a whole semester-long project where you're working with a specific group of people to make some kind of machine learning project, and it's a bit more directed toward a specific goal. This is meant merely to be educational and more general, and also a little bit faster. If you're interested in AIM, talk to either me or Viggy, or I'm just let people around here that are more knowledgeable about AIM.
Basically, it's deploying your ML models to the cloud, like AWS, Google Cloud, or Azure, sometimes you choose to sell. So this type of stuff is like a huge resume boost because you can just say I use these type of MLs on the cloud, shows how you take an initiative, and 100%. At least most people get internships, at least like an interview out of it, right? I mean, that's kind of what we all want. And it's also like a fun environment to learn with a group.
Yeah. So regarding today's agenda, to kind of be a bit more thorough, I'm going to go over what exactly Python is, for those of you that haven't heard of it before, where we can actually code Python. Actually, most of this presentation is going to be figuring out how to use Python. And then I'll briefly touch on Numpy and Pandas, which are two modules/libraries, we'll get into that are particularly useful in Python. That Numpy in particular is used by basically everything, so it's good to know that it exists and know a little bit about it. With that, what is Python? It's by a lot of metrics the most popular programming language as of now. It kind of depends on what thing you're looking at, but in most cases, Python is very well used. And why is that the case? It's a pretty powerful language. You can do a lot with it. You can do, even with like a single line, you can compact so much actual work from the computer in like very small amount of text. It's a lot more compressed than most languages. And it's partially because of that. It's a pretty easy language to learn. It's also for a number of reasons, it's a particularly useful language for stuff like machine learning, which is why we're learning today, as well as data analysis, web development, and pretty much anything else you can think of, mainly because there's so many packages, they're called modules in Python or libraries from most languages, that there's a lot of them in Python, and there are ways to install them very easily, and that improves the functionality of Python immensely. So it's good to know about that stuff. So next, where can we code Python? So again, I'm assuming none of you have heard of Python just for the sake of this. Most IDEs have some level of Python support. So VS Code has an extension for it. There's PyCharm, which, as you can guess by the name, supports Python. Atom and most IDEs you see will allow you to have some kind of Python compiler. So that'll be great. But what we're going to be doing, and what's arguably a bit easier and cleaner, are mainly Google Colab. Jupyter Notebooks is kind of like another version of it. But what this is, it's a pretty easy to use environment that you can go online for. It's, as I said, web-based, and you can kind of combine text and code. So like you can have cells where there's text only and code only, and you can even put like pictures in. You can be a lot cleaner with your code. We'll go over that a little bit more in depth in a minute. But another reason that Google Colab is particularly useful is that you can basically use Google's computational resources, which is really nice for something like machine learning, which is very expensive normally. You can get access to like their Google GPUs and such. So instead of making certain things last like hours, it can last minutes. Or if it would last like days, it could actually be done at some point, which is great. Anyone who can, I would like you, if you have someone to read QR codes, I'd like it if you could scan that QR code. It's basically just an example of a collab. I'm going to go over it on the screen as well, but if it's confusing at first, don't get too worried about it. I'm mainly just showing this now so you have an idea of how collab works. And I might use this every so often to show examples for different basic coding premises. So I'm just gonna open it on my side. On the off chance that you can't access it, this is just a random collab notebook that we've had in the past from a previous workshop. You'll notice it's a little bit different from a typical IDE. You can actually see that there are these cells. You can kind of see on the left where those cells happen, and you can run these independently from each other. So I guess first of all, if you want to try this, if you see on my screen, I'm hovering over the connect button. Connect. Basically, you're just connecting onto the cloud and accessing one of Google's computers to do some of this stuff. Something that's good to do for, it might not do this by default, but generally speaking, especially if you're doing like machine learning, it's good to access resources, go to change runtime, and if it's not already set, add a GPU accelerator. Otherwise, code will run a lot slower for you for something like machine learning. You only get so much of this, like Google rations it to some extent, but they give you a pretty reasonable amount provided you're not working with a ton of data. So I would advise enabling that whenever possible. But for example, if I were to try to run some of this, I could just run this. This is one from someone else, so I can just click run anyway, and it'll just run that code. Something that's not really shown on here is that there was a lot built into the background that there's already Python installed. There's already some other more common modules and stuff already installed to this. So you don't have to deal with all that every single time you run into this. It'd be really annoying otherwise. But this was just importing. You could just run more stuff if you want. You could also make cells. So as I said before, there's a few different types of cells. The two that really matter are code cells, which is where all these are. As you could expect, they have code in them. And there are text cells, which you can just use to write some more in-depth comments. For instance, there's some stuff you can do. So basically, in that case, two pound signs kind of corresponds to a certain type of header, which allows you to be a bit fancier with your comments and be good with your notation. It is very nice to do that. Otherwise, as anyone who's ever coded can tell you, if you don't remember what your code does after the first day, it just kind of gets worthless. It's good to record your progress for multiple reasons. But going back to actually learning Python, let's just open the slideshow again. So speaking of comments, the first thing we're going to go over is writing those. They're pretty simple. If you want to write kind of an explanation without actually putting in code, you can use a single hashtag or pound or whatever you want to call it. And anything within that line from that point onward is a comment and won't be read by the Python. Something that I don't have listed on here is you can also, you can also do multi-line comments. So with what I just showed you, you would have to put a symbol at the front of each line. If you're going to make a big comment, you could have three parentheses on either side of, sorry, not parentheses, quote marks. And basically anything within those quote marks is a comment. So if you have something that's a bit more in depth or is a bit cleaner, if you have multiple lines, that's what you want to use. But not much more to say on that. It's just good practice to do that type of thing. Oh yeah, you have a question?
Is Google Cloud used in the industry a lot, or is it like mostly Jupyter Notebooks? Because I've seen Jupyter Notebooks.
I am personally not the most familiar, but I think it depends on the company. I know at least at the individual levels use a lot. But Jupyter Notebooks is it's functionally very similar. The only real difference is basically using Google's computational resources. So it's going to be pretty similar. But they are used for things. At the very minimum, it's used in research, but it's used in a lot of other places as well.
Thank you.
All right. Any other questions so far before we continue? 3, 2, 1. Sold. All right. So next thing, naturally, if you want to make a hello world, you're going to need to know how variables and printing work. So variables in Python, as a lot of languages, they are case sensitive and unique. So for instance, lowercase x and capital X are different variables. You should name variables that way because that's not very clean and you're going to forget what those do. So try to name something that actually like corresponds to what they actually do, though it depends. There's obviously some variance there. One thing in Python that's different from languages like Java or C++ is that you don't have to specify the data type when you initialize it. They're dynamically typed variables. So for instance, you can see in line 1, there's x equals testing. I didn't have to specify a string. The compiler or the interpreter, I guess, basically just saw that it was a string and assume x is a string. It's not like JavaScript though, so the variable type will remain the same as you go forward. So you can't just say x is equal to testing and then suddenly assume it's an integer, because that's not going to, Python will yell at you for that. Don't do that. It's also kind of bad practice to do that anyway. Printing is also pretty simple. There are a couple ways to do it, but the main way is there's a print parentheses, and provided that everything within here is a string, or at least can be cast to a string, it'll print it. So in this case, it's combining testing and hello world for testing hello world. All right. So speaking of strings, there are a bunch of data types in Python. These are fairly common. I think most of these are familiar to people, except none type might be kind of strange. Basically, Python allows for a data type called none type, which is just kind of like a placeholder that you can use. It's it can be nice in a number of implementations. It's nice to have that every so often. For instance, if you want to like set a variable to not be anything until there's like a loop, you might want to set it to none to begin with. But otherwise, these are pretty straightforward. Does anyone have any questions so far? Yes?
I know for like Java, there's also doubles. What's the difference between like a double and a float?
It's just a matter of precision. In most things, it won't matter. I want to say there's some kind of double for Python as well, but for most things, it won't matter. And as I said before, a lot of this will be just interpreted by the Python interpreter. You don't have to specify it necessarily, except in some cases, but it'll just assume based on what it gets. Arithmetic. So again, this is pretty similar to a lot of languages. There's addition, subtraction, division, modulus, mod, which is just remainder basically, multiplication, floor division, and then power. They're pretty simple to look up. It's pretty straightforward, but I figured I'd go over it just for simplicity. Don't think there's really much to talk about here. More just important to know that it exists. And the syntax is pretty similar to most languages, so I'm not going to linger on this. Comparison and logic operations. So one thing I do want to point out is the and, or, and then nots. Unlike something like Java or C++, they're actually spelled out. Instead of using like a specific symbol for or, it actually just says or. Same thing for and not. So it's important to know. It's a little cleaner to see, but it might be a bit of a culture shock if you're coming from a different language. But you'll generally like it. It's a lot easier. It's a bit cleaner to work with. If you need to actually do some kind of decision making in your language, you're going to need to use some form of decision loop. So this is an if-else, how it works in Python. It's largely the same as other languages, but there are a few notable differences. First of all, if you're coming from Java or C++, there's no parentheses around the thing. It's not necessary in Python. So in C++, you would have to like put parentheses around the A, for instance, but you don't need to do that for Python. Also, instead of writing else if, in Python, they decided to just concatenate it, just combine it, and just say elif. It's functionally the same. It's just how it looks in Python. Probably the most important thing here, though, is indentation. Compared to some languages, sometimes indentation is just used to make code look clean and do things like that. In Python, it functionally affects your code. If there wasn't the indentations here, this wouldn't compile, or this wouldn't be interpreted correctly. You'll notice that there aren't any curly brackets around any of these conditions. The indentation is basically what takes that spot. So anything that's indented one space over would be what that first if runs. And that can go branch within itself. So you can have an if inside there that's indented once more, and so on and so forth. So you do need to keep track of indentation, or code will not work well. Fortunately, it does force you to code with indentation, so it can be nice in terms of keeping code clean, but it's something to keep track of. So now going on to some data types that are a little bit more complicated. We have lists and tuples. Notably, there aren't any arrays. We'll get to that later. But basically, they're the main thing they use in base Python to go over a group of different values. Interestingly, they don't have to be the same type. So I don't have it on here, but the next page, you'll see that this list has like a bunch of things. It has string, it has integer, it has none in there, it has true. They don't have to fit. It might affect how your program actually runs, but in Python, that is all legal and it all works. The difference between lists and tuples, they're very similar, is that a list can be changed, so you can add or remove elements from a list, but a tuple is constant, so you can't change anything in this tuple, which is, depending on your what you're trying to do, can be good or bad, because you might not want to have a tuple in a case where you don't want to accidentally mess up and change a tuple value where it shouldn't be. So that's good to know. Like a lot of languages, for how you access arrays in C++ or Java, for instance, you just can access different elements by index. So for instance, fruits 1 is just tomato in this context. If you say it is 0 index, so if you did fruits 4, you get an error because that's outside of your list. And then for lists, we can't do this in tuples because, as I said, they're immutable; they can't be changed. For lists, you can change value just by getting its index. So you can set fruits 2 equal to third fruit because I'm unoriginal. And you could just do it that way. It's the cleanest way of doing it, and it works. To give a bit more in depth with the lists, you can do some stuff with it. As I said before, you can add elements to a list, and you would do that via append, which you can see on line 4. So in that case, I show what the results of this all is on the bottom. So you can see that orange gets added. For remove, that's a bit different. It'll basically just remove the first copy of the element it sees. As I said, this does work despite the fact that the data types are different. So if I wanted to remove true, it's going to remove the first true. So it'll remove the true before green, but it's not going to remove the one after. There's also there's just a length function that basically just gets the length of a list, obviously useful for loops and such like that. There's a lot more than just this. This is mainly just an introduction, but there's a lot you can do with lists. Though for reasons I'll get into, they're not always the best choice. If you've ever used something like Java or if you use Java, there's something called an array list. What you're often told about that is it tends to be slow relative to something like an array. So when you might, I'll show an alternative later that's a bit better than a list in that regard, but for a basic program, it won't matter. Are there any questions before I go any further? All right, that's nothing. So next, kind of going on similar theme as before, we have dictionaries. This is not something that it's similar to things that you can see in other languages, but the way they work is it's a pairing. There's two lists. There's a list of keys and there's a list of values. The keys can be used as indexes to get values. So for instance, for a certain dictionary I can say my dictionary Wednesday, and the value would come out as, I'm not going to say that, but it's that blob of text, that third one right there. It can be nice when it can be nice for dealing with some things where indices might not be enough, and yeah, each key has to be unique for I think pretty self-evident reasons. But in terms of how the syntax works, you can see there's a few ways of doing this, but the most basic way of initializing a dictionary is you would just use some curly brackets, and then you would put a key, colon, none, or whatever you want it to be. I will note that the keys don't necessarily have to be strings. They could be integers. They could be, as long as it's something that I think in Python you have to get that can basically conform to be hashed. They can turn into a single integer value. So certain things you can't use a list as a key, but a string would work, an integer would work. Don't know if Boolean would work. That'd be weird, but you could do that if you wanted to, I think. But that's how you initialize it. Then I could set a value. So Tuesday. Well, actually, I'm just getting a value in this case. So for instance, on line 11, I say Tuesday classes. I can just get my classes and then in square brackets Tuesday, and it'll look for the Tuesday option, which in this case is CS 4384 and 4349. Then let's just say I forgot that a certain section also meets on Monday. So I can change a value in the dictionary by just saying the key Monday is equal to this single list. I will add that you can add, if Monday wasn't on there, it would still work. It would make a new key for you. it's not like you have to say all the keys from the get-go. So you could just start with an empty dictionary and just add things as you go, which can work in a lot of cases. Did I forget to list something on here? No, I think I do have it all here. So that's basically how dictionaries work. They're very nice in a lot of cases and a little easier to work with than similar things you can do in other languages. So loops. If you don't want to repeat the same program, repeat the same code like 100 times, or in some cases it's just straight up not possible to do a certain program without a loop because you won't know how long to continue something, you have while and for loops, just like in many languages. They work a little bit, for loops, which basically allow us to iterate over a set number of values, work a little bit differently than something like C++'s for loops. Instead of by default going over an index, it goes over a list or something like a list, which that part's not that important. But basically, if you see this first example, for item in item list, within this loop, so starting on line 4, item will just be an element from the item list. So in this case, it'll just print out 1 false computer and -0.231. So in some ways it's cleaner, in some ways it's worse. If you want something more like a more standard for loop, you can basically use something called a range, which will generate values between 0. There's more complicated ways of using it, but basically in this context, it'll get all the values between 0 and 4 and make it into a list. And so in this case, it'll print 0 for 4. While loops are, again, if any of you have coded, you would know what this is, but if you don't know what this is, it's a loop that continues until the condition is not met. So it'll do it while this is true. In this case, I set it so that while a is less than 10, print a, and then increase a by 2. If I did put the a there, the a plus 2 plus equals 2, it would just continue indefinitely, and that wouldn't be great. You like code to end at some point generally. So you want to make sure that your condition eventually is satisfied by some means. If you do want an infinite loop for some reason, you could, for instance, say while true, and just anything in there is just going to continue indefinitely, unless you do some things with it. But basically, that's how while loops work. It's nice when you're not quite sure how long you want to run on a list. Right, functions. So functions are good. Basically, they allow us to just take some type of functionality in our code. So for instance, let's just say we want to check, if I want to be really basic here, say if a certain integer is even or not, you can make a function for that. So you could do define function, you can just call it is even, and then you could take in a value, let's just say x, then you could do some other functions. And if you want the function to actually return something, you can say return whatever you want to return. Unlike some languages, you don't need to define what it returns necessarily. If it doesn't return anything, it technically returns none. But you could also just have it return, say, an integer, a string, a list, a tuple, a list of dictionaries if you want to be weird. I don't know. There's a lot of things you can do here. To give a more concrete version of what I just said, even is really simple. It's just returning x modulo 2 is equal to 0. So if x can be evenly divisible by 2. And then this is kind of a bad example because it's such a small function, but you could just call is even just like that, and just check that way more quickly. Not necessarily more quickly, but it's cleaner from a coding perspective because not reading any functions is a good way to not know what your code does. So that's how that works. Any questions about this? All right, that's nothing for me. So just to briefly go over some additional things outside of base Python. I mentioned before how normal Python doesn't have support for arrays. Numpy does. It is something that's used in most Python languages, most Python programs and most Python modules. If you want to use NumPy, you'll see on line 1, you have to put something in like this. So import NumPy. You could just leave it at that. If you want to be brief, you could say as NP. So whenever you're referencing NumPy, like for instance on line 3, you would just use that miniature NP instead of writing NumPy. And import NumPy as NP is pretty standard by most languages. This is what you'll see most of the time. But yeah, basically they work as arrays normally do. So the actual size remains the same, but they're they're generally a lot more computationally, they're just faster. And there's additional support within NumPy that allow you to do certain things more quickly, such as, say, get the minimum of a list. Get the minimum of an array, get the standard deviation of an array, add everything in the array by a certain amount. There's a lot you can do with it. Also, something to note: unlike lists, the data type has to be the same throughout. So in this case, I specify a D type of np.float16, which is just a 16-bit float. And you can basically see a few things from it. So as you might know already, arrays and lists, they don't have to be one-dimensional. They can be two-dimensional or three-dimensional. So you can check how many dimensions there are, what the shape of the array is, data types it has. And they're generally pretty nice, and they're used in a lot of things. We'll almost certainly be using this later on in our ML Mondays, but it's good to know this stuff. Pandas is another one that's used a lot. This is great for anything basically any kind of program that's dealing with tabular data. So like an Excel spreadsheet or something like that. This is a way that the program can very easily make sense of it. This isn't as clean on my side. This is basically making a data frame from scratch. So it's making basically a table with row 1, row 2, row 3, column 1, column 2. Very boring names, I know, but at least they're clear. And you can do different things like, there's a bit more functionality here than you might otherwise see. You can get the entire row, you can get an entire column, you can get a specific element of a row. In addition, something that's really nice, you'll see on the actual collab, and this is what's used a lot for data frames, you'll see something like pd.read some file. It's usually CSV. It'll basically take in that entire spreadsheet and turn it into a data frame, which is really nice. It saves you a lot of time. So the entire program already has all of this information in it. And sometimes we'll have much larger spreadsheets, but it can make things a lot easier. There's even stuff like describe, where it'll like give you specific statistics about each of the rows and such, which is very nice for a lot of reasons. I'm not going to go into that because that's some more advanced stuff. But need to say, Pandas is really nice. As I said, this would be fairly brief, but any last questions from anyone? I guess.
Will you be sharing the slides?
We plan to. We'll let you know. It'll be in the near future. But the slides will be released, as will the other slides we'll get into as we progress. Any other questions? Yes?
I mean, considering that Pandas does a lot of statistics for you, how much statistics do you think we need to know in our head?
One thing to learn about coding is that people don't necessarily learn how to code better. They learn how to look up code better. It's good to know that these things exist, so you know what to look for. That's part of the reason that we're not showing everything from scratch. There's just too much to learn and too much to memorize. It's better to just know, hey, this is Pandas. If there's certain functionality, it probably already exists because it's a pretty good module. And that's basically the idea. Any other quick questions? All right, sold. So I guess to end it off, AIS wanted you guys to do a survey. This will give us some information in terms of marketing, in terms of getting people more aware of ML Mondays. The next few will be a bit more interesting. As I said at the beginning, the schedule next week is going to be about tabular machine learning. So imagine an Excel spreadsheet and just doing some machine learning off of that. That'll be where we start getting to the real core of things. Today, again, is just a prereq to get everyone an understanding of how Python works, which is what all of this is going to be in. All right, I think with that we are done.